Okay, so a worked example or a look at one of these as promised. So I'm going to pick experiment D first of all and use that as an example. We've got the information from the table there. What I've done, I've tried to sort of lay out how to do the calculation in a little bit more of a straightforward manner. Okay, so looking at experiment D, I've drawn up a little table here showing basically what we're being asked to do in question one. So in question one, we're asked to look at the mass of each of the reactants that are listed and then work out the number of moles. Now, if we do that for experiment D, we had no ethanoic acid and no ethanol to start with, and we had 2 centimeters cubed of the ester, so ethyl ethanoate. So 2 centimeters cubed of that, we're going to multiply that by the density, which was 0.9. That gives me a mass of 1.8. Okay, I then divide that by the relative mass, which is 88, which gives me a number of moles of 0.02. Question 2 is asking us to look at the titer value for the second titration, the HCl, and we did that one, and looking at the results that we had for this particular example, it was 16 centimeters cubed. The concentration of sodium hydroxide is 1, so the number of moles is going to be the concentration times by the volume in decimeters cubed. So the concentration is 1.0, the volume in decimeters cubed is 0.016. So the number of moles of HCl is 0.016 moles. For question 3, it then asks us to consider the mass of the water in HCl. Now, HCl had a density of 1.05. So the mass of 5 centimeters cubed of HCl was 5 times by 1.05, which gives us a total mass of 5.25 grams. The mass of water within that, just go back a step. We need to get a mass of HCl here. So to change this into a mass, I'm going to multiply that by 36.5, which gives me a mass of 0.584 grams. That is the mass of the HCl dissolved in the acid. Then, going on to here, we had a total mass of the liquid HCl, the solution HCl, of 5.25. To work out how much of that was water, I'm going to do 5.25 minus the mass of the HCl, which was 0.5584. So 0.584, which gives me a mass of water, in this experiment of 4.66 grams. So that's the mass of water in the mixture which comes from the hydrochloric acid. If I just scroll back up, in this experiment, we put 3 centimeters cubed of water in. So the total mass of water then is going to be 3 grams from the 3 centimeters cubed that we added, plus 4.66 grams, which gives us a mass of water, a total mass of water of 7.66 grams. To work out the number of moles of water, I'm then going to do 7.66 divided by 18, which is the relative mass. So I do 7.66 divided by 18. That tells me that I've got 0.43 moles of H2O in my equilibrium mixture, or in my mixture to start with. Then, question 5 then asks us to look at the amount of ethanoic acid which was there at equilibrium. So the first thing we're going to do is we take the difference in the titer values. So the first titer for this group was 34.7 centimeters cubed, and the second one was 16.0 centimeters cubed. If we take the difference of that, then we get 18.7 centimeters cubed. This is the amount of sodium hydroxide needed to neutralize the ethanoic acid. Okay, so we're then going to say if it was 18.7, the concentration, remember, of sodium hydroxide is 1 mole per decimeter cubed. So again, number of moles is going to be concentration times volume. So it's going to be 1.0 times by the volume in decimeters cubed, which was 0.0187 decimeters cubed. Okay, so the number of moles of ethanoic acid at equilibrium is 0.0187 moles. Okay, so then we go on to look at what we've got. So if we go, initially we had no ethanoic acid. Okay, if we go back up to here, we have no ethanoic acid and no ethanol in this mixture. So no ethanol, and we had, as we've calculated, 0.02 moles of ethyl ethanoate and 0.426 moles of water. The final number of moles of ethanoic acid we've calculated as 0.0187. That means that the number of moles of ethanol would be the same. However much these two have gone up by, these two will go down by the same. So we're going to do here minus 0.0187, which gives us 0.0013 moles. And here it gives us 0.407 moles. And then the concentration, to work out the concentration, we're going to divide by the total volume, which was 10 centimeters cubed, so it's 0.01 decimeters cubed, which means that we've got a concentration here of 1.87, a concentration here of 1.87, concentration here of 0.13, and a concentration here of 40.7. So we then put those numbers into our expression for Kc. So that is going to be 0.13 times by 40.7 divided by 1.87 times 1.87. That gives us a value of Kc of 1.51.